Welcome to qnawire.
Problem 113 asks what the mole fraction of chloroform is if equal masses of carbon tetrachloride and chloroform are mixed together. And then it asks you to condense the vapor above such a solution and figure out what the pressure of chloroform is above that new solution. So the problem gives you that the vapor pressure of pure carbon tetrachloride is 0.354 atmospheres, and the vapor pressure of pure chloroform is 0.526 atmospheres, both of these at 316 Kelvin. So given these two bits of information, we know from this section in the textbook that partial pressures of volatile liquids such as carbon tetrachloride and chloroform can be figured out independently and then added together to give you the total vapor pressure above a solution that's a mixture of the two. To find out the partial pressures of each of these volatile chemicals, what we would have to do is find the mole fraction of each of these chemicals, multiply that by the vapor pressure of each pure liquid, and then add those two together. So let's say, based on the problem telling us that we have equal masses of these two liquids, let's just say that we have 100 grams of each. So we know that the molecular weight of carbon tetrachloride is 153.82 grams per mole. And if we know that we're going to call each of these masses 100 grams, we can divide 100 grams by the molecular weight of carbon tetrachloride to figure out how many moles of this particular liquid we have. So that's 0.650. We can do the same thing then for chloroform. Because we have equal masses, 100 grams divided by the molecular weight of chloroform, which is 119.38 grams per mole, which gives us 0.838 moles. So now what we have to do is use these two molar amounts to find the mole fractions of each carbon tetrachloride here and chloroform, and we know the pressures of pure carbon tetrachloride and chloroform. So you can plug them into this equation here. So the mole fraction of carbon tetrachloride is the number of moles of carbon tetrachloride over the number of moles of both substances combined. And we know that the pressure of pure carbon tetrachloride is 0.354 atmospheres. We can do the same thing for chloroform. And again, we know from the problem the pressure of pure chloroform. And this gives us a total pressure by solving this here of 0.451 atmospheres of this first solution. So starting a new page, we know that the solution pressure is 0.451 atmospheres. And we know that the partial pressure of chloroform is 0.296 based on the math we just did back here, this portion here. And so if we if we divide the pressure of the chloroform component by the total pressure of the solution, that gives us sort of the fraction of the solution that's actually chloroform. That comes out to 0.657 atmospheres. So the answer to the first part of the question then, the mole fraction of the chloroform of vapor above this first solution is 0.657. Sorry, the atmosphere shouldn't be there because it cancels. Now we know that the vapor of this first solution then is 65.7% chloroform and 34.3% carbon tetrachloride. If we were to condense that, the solution resulting from this vapor would have the same proportions of chloroform and carbon tetrachloride. So what we can do here is then take the same equation. The pressure of the chloroform component is equal to the mole fraction of chloroform multiplied by the pressure of pure chloroform. So again, this mole fraction is 0.657 because this vapor is condensed, giving the same mole fractions for chloroform and carbon tetrachloride as the vapor of the previous solution. And we know that at this temperature, 316 Kelvin, that the vapor pressure of pure chloroform is 0.526 atmospheres. So what that tells us is for the second solution, this condensed solution, the pressure of chloroform is 0.346 atmospheres.